Hey, I know what's wrong with your truck. It's your quote-unquote pollution controls. I heard on talk radio you don't even need them. They're just an egghead government plot.
How is cutting down on pollution a government plot, Dale?
Open up your eyes, man. They're trying to control global warming. Get it? Global.
So what?
That's code for UN commissars telling Americans what temperature it's going to be in our outdoors. I say let the world warm up. See what Boutros golly thinks about that. We'll grow oranges in Alaska.
Dale, you giblet head. We live in Texas. It's already 110 in the summer, and if it gets 1 degree hotter, I'm gonna kick your ass. What in God's name is that thumping sound?
Oh, the good old days of King of the Hill. All right, well, here I am, and greetings and welcome back. We head into chapter 4 this time around, physical geography. We're going to be taking a look at weather and climate, and that leads to a question, what is the difference between weather and climate, which looks like a good quiz question. What is the climate in your area where you live, where you're from? The climate of your campus. I know where Mount Aloysius is. It's probably not too different from. I'm a county or so down. I'm in Somerset, so it's probably not too different. So let's get into this. Get my screen share going again, and boom, there we go. Physical geography, weather, and climate. I'm going to do something a little different from here on out. Instead of watching you guys see me type in the white space, the electronic chalkboard live, I'm already going to have it there for you, and you can copy it down as if it was a PowerPoint or something, and pause it after I talk about it or before, however you like. And it will cut down on my the time of the video. So in this chapter, we want to differentiate between climate and weather. We want to investigate the development of air moisture and understand the major causes of climate change. A couple of less than usual heads up terms this week: reflection and re-radiation. Reflection is that deflected solar radiation. It doesn't make it to the Earth's surface, and we'll talk about the detailed elements that do that. And then re-radiation, the received radiation from the from the sun that reaches the Earth's atmosphere and then makes it back to the atmosphere. So, air temperature. I just want to say this about air temperature before I have some notes for you to write. We're looking here at elements that constitute the weather, right? Temperature, wind, precipitation, and these are all recorded at specific moments in time, such as every hour. So let's look at air temperature, weather, and climate. So by finding trends and data that have been gathered over time, we can speak of characteristic circumstances as a region's climate. Temperatures vary. Temperatures vary because of differences in the amount of solar energy that get received from place to place. And the factors responsible for the variations in solar energy are the inclination of the Earth, right? How the Earth is tilted. Reflection and re-radiation. We're going to talk about that in a moment. The storage capabilities of surface materials, such as soil, water, and cloud cover. Now, as we start to move into reflection and radiation, I would ask you to, for you visual types for sure, to turn to page 79, figure 4.8. Reflection. Reflection is the solar radiation that gets sent, deflected back to outer space. For example, clouds, dense concentrations of water, ice, and snow cover, all reflecting much energy. Re-radiation is received energy that gets returned to the Earth's atmosphere. For instance, some clear nights, right? In clear nights, the temperatures are cooler because they are unblocked by the clouds. If you take a look at the illustration on page 79, you can see that. Let's start moving to air pressure and winds. I would say this too, as we look at it, before we look in the rear view mirror at reflection and re-radiation. The warmer the object, right? The warmer the object, the more energy it's going to emit. So all objects above 0 degrees, to be really specific about it, will emit some kind of radiation. So air pressure and winds. Air pressure and winds. The difference, before we get into the fills here, the difference in air pressure from place to place, that is what affects your weather conditions. So your gas substances, looking at the fills here, gas substances which make up air pressure affect the pressure. So basically, air pressure it's heavier and higher the closer to the Earth's surface. Cold air is denser than hot air. Think about it. Your hot air balloons, right, are filled with lighter air. So when air heats, there's a drop in atmospheric pressure. And there's a rise in pressure when it cools. I mean, just for those of you who have flown, think about how your ears feel as you begin to descend to the Earth's surface. The pressure accelerates as it gets higher and heavier. Now, by Wednesday, I'm going to have you guys do a graphic organizer. You have to fill in the graphic organizers. Go back over this lecture. But on that, I have a nice visual, homemade visual of this process. I'll talk about it here. You can see it on the model of the graphic organizer. The higher we go, just to say this in another way, the higher we go, the air molecules become more widely spaced and diffused. They spread out. So the increased space between gas molecules in the air then results in lower air density and lower air pressure. So, another way to look at this: the higher you go, the lighter air. The lighter air, because of hot air, right? And there's a drop in pressure. The lower you go to the Earth's surface, there's a rise in pressure. Higher or higher air equals the higher air pressure equals cold air. So to add to that, the factors that affect energy receipt and retention, they create these high, heavy, and low, light air pressure factors. In fact, turn to, as I explain this for a nice visual, turn to page 83, figures 413, 414, as I talk about this. So the air moves from high to low pressure, really in an attempt to equalize the pressure. And you can see this there with those visuals there. You have horizontal movement. The horizontal movement is the wind, and the vertical movement is the convection. That's where your light air is rising your heavy air is descending. In figure 415 over on page 84, you have your Coriolis effect, right? Coriolis effect causes winds to veer away from a straight path. In fact, let me, your author, if I remember correctly, has something good to say about the Coriolis effect. Yeah, the straight arrows, if you take a look at page 84 there, the straight arrows indicate the paths that winds would follow flowing out of an area of high pressure or on the one of low pressure. And were they to follow the paths dictated by the pressure differentials. Now the curved arrows there represent the apparent deflection of the Coriolis effect. And wind direction, indicated on the diagram by the curved arrows, is always given by the direction from which the wind is coming. So you have a number of latitudinal wind belts that you can see too on these graphics. Latitudinal wind belts with these consistent patterns of surface wind movements that, well, they move seasonally, north or south, in concert with the seasonal changes in solar energy received at the Earth's surface. So just kind of putting a wrap on that section, the wind direction patterns, in addition to differences in water density, they set the ocean currents in motion as well. And we talk about water density, we're talking about salt and minerals that basically don't evaporate. And you could see this on page 86, figure 417. Start getting into moisture in the atmosphere now. So air contains, just setting this up a little bit, air contains water vapor, which is the source of all of the precipitation that we know and love, right? Precipitation is any water, is water in any form. Rain, sleet, snow, hail, which gets deposited right on the Earth's surface. Well, let's take a look at that precipitation here. Look at your fills. Precipitation, that's water vapor is the humidity. Water vapor is the humidity. And this is the origin of all precipitation. So what you have here, you have air that falls from the atmosphere onto the Earth's surface. So air is hypersaturated, supersaturated, in that it carries a great volume of water vapor. So when the vapor changes from a gas to a liquid, it condenses. It condenses, forming fine particles called condensation. So let's break down condensation. I'm thinking this looks like a good quiz question here too. The condensation breaks down in particles: dust, pollen, smoke, salt crystals. And these particles are usually not heavy enough to fall, but they become larger droplets when they do happen to combine. And at that juncture, they're just too heavy to remain suspended. So they fall as rain, and then of course when the temperatures go beyond freezing, they form ice crystals out of these water droplets, creating snow and so forth. And page 87, figure 419, give you a nice visual as well. before we get into air masses, just again put a kind of a cap on this section. The the rain droplets or ice crystals, um, in large numbers, they will form clouds. And you can turn to page 90 as I talk about this. Page 90, figure 421 and 422. So these rain droplets or ice crystals in large numbers, they form clouds, of which there are many, many types of clouds. You have kind of broken down under the umbrellas of the um, convectional type of cloud, and then you have your orographic types of clouds, and also your, I should say, your cyclonic uh, precipitation as well, or frontal precipitation that you could see at probably over on page 91, I think it is. So, weather forecasters in each location on Earth, they've got to deal, right, with these elements of weather in context of the local environment, which leads me to break this down even further into talking about air masses and looking at your fills here. Air masses are large bodies of air with similar temperatures and humidity characteristics forming a region's source region. And you can turn to page 424, page 91, and figure 425. And while you're doing that, I'll just say this about source regions. A source region is an area where your air mass originates. And they originate in primarily in deserts, oceans, any any large landmass, right? Um, Small elevations, variations, but not a combination of land surfaces. So just enlarging on this, the front, and you can see this over on page 425, 426, figure or page 92 and page 426. The fronts separate the cold, dry air from whatever air is in its path. For example, if a warm, moist air mass is in the way of a polar air mass, the denser, colder air is going to grip it, right? Going to grip the ground, forcing the lighter air upward. So as the frontal air as it rises will condense in what we call frontal precipitation. Again, figure 426, page 92, nice visual on that. Before we get into the last section, I want you guys to know climate change. I just want to talk about some special conditions that make places susceptible to tornadoes, hurricanes, smog, or heavy rain. Your lab, as a matter of fact, will address this. You have a really cool lab. Of course, I always say that. I think all these labs are cool. It's going to be a lab on current watches and warnings that's put out by the National Oceanic and Atmospheric Administration. But special conditions that make places susceptible to tornadoes, hurricanes, smog, or heavy rain. And then I want to talk a little bit here about climate, soils, and vegetation. The climates of the world can be broadly classified by considering seasonal temperature and precipitation conditions. Then you have your climate regions. And you can turn to page 94 to 97 for what I'm going to talk about here. Each of the major climate regions have classical characteristic natural vegetation areas. Your soil types also tend to be associated with climate because of their strong relation to certain vegetation types. And with that, you have like foods that are generalized by their climates. Think about your Mediterranean area, with the dates that are grown there, and grapes and figs, and your dry summers and your moist winters. Chinese climates, you have your wheat noodles in the north and south. You have your your rice dishes. Page 94, 95, figure 430. Talks about the major climate regions. And you have on page 96, you have your 10 major climatic zones. You have your tropical rainforests, your savanna. I'm going from the warmest to the coldest. Tropical rainforests, your savanna, your hot desert, your mid-latitude semi-desert, your Mediterranean climates, probably most popular. Your humid subtropical, which is more or less what we are here in southwestern PA. Marine west coast, that'd be your rainier climates, like up in the Pacific Northwest, England. Humid continental, and your subarctic. You're getting your really bad ones now. I'm sorry. Your humid continental. Humid continental would be that would be where our types of climate, and then your subarctic and arctic, right? Bad ones that we don't like, right? At least most of us don't. I know someone who complains about summer, and I always scratch my head. I say, you do know that most people, when they're retiring, they're going to the Sunbelt states, not to, Sudbury, Ontario. Lastly, we're talking about climate change, and here are the notes for that. Among the theories of climate change, you have, well, I would just say this, is a topic of great current interest is climate change. And there's a lot of debate about the amount of change that climates are undergoing. And there's a number of theories of climate change that have been put forward. So your notes, if you wanted to hear me first or after, the cyclical change of the Earth's orbit around the sun, right? You have the changing tilt, the effects of volcanic eruption, and the effects of human civilization. So the first would be the shape of the Earth's orbit around the sun. It changes over time from circular to elliptical, and the elliptical type is a closed curve. So when it's circular, the Earth is generally colder. When it's elliptical, the Earth spends more time near the sun. I want to take a look at some of these. I want to take a look at the elliptical, and you can see the circular type of orbit. And then here's the elliptical, like I was talking about. The Earth during those types of orbits spends more time near the sun, so it's warmer during those types of orbits. The elliptical. Point 2, climate change. Well, the tilt of the Earth's axis, right? As the angle of the tilt changes, solar radiation hitting the poles change as well. Then you have volcanic eruptions. Volcanic eruptions, very powerful sources. And then lastly, probably what's up for a lot of debate, the effects of human civilization. And let me just say this real quickly. I know I really emphasize it in the term paper topics, but I want you, for whoever takes on that paper, those subjects, I want you to look at this from solely the viewpoint of those who feel like, and this would be the argument to the man-made climate change deniers, global warming deniers, they're saying if you take a look at all of those, the former three reasons for climate change, they dwarf anything we're doing down here, and they've been going on for a very, very long time, and they will continue to do that. And then they get into how manipulating fossil fuels and so forth is job killing and all that, which is beyond. And we'll get into that in chapter 13. But so when you take on those papers, I do not want you taking it on from the conventional standpoint of the Earth is warming because of man-made activities. I don't want you doing that. I want you to look at it from the vantage point of really a side that you don't hear from very much. And I'm not taking a side here. I think, in fact, I know one of my major philosophies of education is if there's a legitimate viewpoint that is not conventional wisdom, I gravitate that way. And that's the way I want my students to be thinking, right? Or at least learning. So, all right, I riffed on that. Just kind of wrapping this up here. In recent years, a number of scholars have come to believe that the Earth is getting warmer due to an increase in global warming produced by artificial burning. In the early 70s, some of these same theorists were forecasting a global freeze by the turn of the century. Opponents cite, and I kind of reiterating what I just talked about, I guess, opponents cite regular cycles of global warming and cooling. They also state that gases emitted from oceans and volcanoes will dwarf any man-made emissions. So there you have it, chapter 4. Where are we going this week? Let's see here. Where am I going next? Yes, up ahead, Tuesday. Got some short videos, and I'd like for these to be incorporated into the discussion questions. But it's also for those of you who learn by the audio visuals. These are often helpful. Wednesday, I'm going to give you guys a graphic organizer. I didn't give you one now. I want you to go over that, and I'm not going to recap via that right now. I want you guys to go over the lecture notes and fill it in, right? Fill it in as a comprehension exercise. So that will be on Wednesday, due Wednesday night. Thursday, you have your lab, which I had mentioned earlier by the National Oceanic Atmospheric Administration, and is basically watch warnings and current weather conditions. So you'll tell me about, what's up ahead in regard to weather, and what's, up ahead in the next week, maybe, and what's going to happen in the next couple of hours. Really cool website. Friday, right, you guys know the drill. Your first discussion post, we do 11:59, and then Sunday, your 2 response posts. Monday, boy, just moving along real fast here. We begin chapter 5, and then we really get into this from there to the end of the course. Practically, we start getting into things that students are like, wow, I just didn't know that was geography, population geography. Again, I think this stuff we're looking at now is really cool, coming up, really super cool. And I trust that by the end of this course, you guys are going to, history's good, psychology, sociology, and economics and all that, really good stuff. But, I'm thinking after geography, you guys will, it's kind of like listening to a really great guitar solo by a great guitarist and then hearing a good guitar solo. It's like, so there you have it. Questions, comments, concerns, get a hold of me immediately, right? So you guys have a fantastic week. Do well in everything, right? And I will see you next time. So, bye.